In this video, we'll talk about compound interest and compare with simple interest. Compound interest is the type of interest that's earned from savings accounts and annuities, and it's also the type of interest that is charged for credit cards. So first, let's look at an example and compare these two. Suppose that $5,000 is invested for 3 years at 8%. Let's find the amount of simple interest first. Well, simple interest, we had a formula, I equals PRT. Okay, and so the principal is $5,000, the starting amount. The rate is 8%, 0.08. And then the time is 3. All right, so multiplying those three together would give $1,200. So that would be the simple interest over 3 years. Now let's find the compound interest if interest is calculated once per year. And hopefully this gives you an idea of how this type of interest works. All right, so at the end of the first year, okay, let's make that calculation. So year 1, and let's calculate the interest. Okay, so we still use I equals PRT. All right, so we would have $5,000, 8%, but this time the time period is just 1. Okay, we're calculating this at the end of the first year. And that would give $400 worth of interest. And that makes sense since we know that it's $1,200 for 3 years, $400 is a third of that. Okay, so that's as expected. Now, let's see what happens in year 2. Now, here's where compound interest is different. Instead of just making the same calculation again, instead, that $400 would be deposited, like if this is a bank account, that $400 would be deposited into the bank account, and then you would, in year 2, earn interest on that amount as well. So the new principal is not $5,000 anymore, it's $5,000 plus the $400, all right, $5,400. The rate stays the same, and so does the time period because we're only looking at the second year now. Okay, and that gives $432 worth of interest. It should be a little bit more because you're earning interest on a little bit higher amount. All right, and then let's see what happens in year 3. Now the principal is that $5,400 plus the interest that was earned during year 2, the $432. So the new principal for this year is $5,832, and same rate, and still for 1 year. Okay, and that's $466.56. All right. So altogether now, if we wanted to find the total amount of interest using compound interest, okay, if we add these three, okay, the $400 from the first year and the $432 and $466.56 from the next 2 years, then that gives a total interest amount of $1,298.56. Okay, so you can see that it is a bit more with compound interest. Now let's look at how we would develop a formula for compound interest, because imagine, you know, if the time period had been 10 years instead of 3, okay, we would have had to repeat this process 10 times in order to find the amount of interest. There was no way to just directly calculate it. So here we go. Now let's start out with this formula for the future amount, and let me remind you where that comes from. If you multiply principal times the terms in parentheses, we get A equals P times 1 plus PRT, okay, and PRT is the formula for interest, okay, so we're using that future value formula from section 8.2, which said that the amount in an account is the principal plus the interest. All right, so I'm just choosing to work with the different form of that equation. All right, so here's the calculation for the first year. Okay, if we wanted to know the amount in the account, it would be 5,000 times 1 plus 0.08. Okay, and if you quickly work that out, that does, just as an extra check, that does give $5,400, right? So that's the $5,000 principal plus the $400 that was earned in interest. Now the second year, the only thing that's different with compound interest is that instead of using the original principal, we're replacing that with the principal plus the interest. Remember, we replaced it with $5,400. Okay, so this part in blue, this is the first year amount. This equals $5,400. Okay, and then here I'm multiplying times 1 plus rate times time. Okay, and here t is just a 1 because I'm calculating it once per year. Okay, so then that gives the second year. And I've written this in a slightly different way using exponents. So notice we have 5,000, and then we have two of these factors, 1 plus 0.08. Right? So remember that when you have two of those, you can write that using an exponent, or squared. Just like if I had, 3 times 3, I would write that 3 squared. All right, so that gives me the amount in the account at the end of the second year. Now that becomes the new principal at the start of the third year. So I'm replacing that in this formula for the principal, and then doing the same thing, timesing it by 1 plus RT. All right, so again using exponents, we have 5,000, and then I have two of these 1 plus 0.08s plus another one, so 3 altogether. All right, so I write that 5,000 times 1 plus 0.08 to the third power. All right, so if you notice the connection here, there's a pattern between the number of years, okay, that we've made this calculation, and that exponent. All right, so you can guess, at the end of 10 years, rather than having to go through this long process 10 different times, instead of doing that, okay, we're back. After doing that for 10 times, right, instead of that, I can use the shortcut formula. I know that it's going to be 5,000 times 1 plus 0.08 to the 10th power. All right, so let me encourage you to try this out. You know how to do this the long way now, so continue this on. Try a few more years, like maybe not all the way 10 years, but try this for maybe the first 6 years, something like that, and then try this new formula that we've developed, okay, with an exponent of 6, and just check and see if you get the same thing. Right. Now, if we wanted to generalize this, what would it be after t years? Well, after t years, it would be principal times 1 plus RT to the t, okay, whatever t is. All right, so, okay, so here we have it, and this was compounded annually, so that's why you don't see a t here. If interest is compounded once per year, then we used a 1 for that period of time, each time we made that calculation. All right, so the only other thing that we need to do to completely develop this formula is to talk about what if interest is compounded more than once per year. So some common terms would be semi-annually, twice a year, quarterly, 4 times a year, monthly, or daily. So you can check your bank account if you happen to have a savings account that earns compound interest, and see when your dividends are posted. It's not really going to say on your bank statement, compound interest or something like that. Usually it will say dividend or dividends posted. My savings account dividends post quarterly, right? So I'll see those every 3 months. Another common one would be monthly. Maybe you do get dividends at the end of each month. All right, so there are 2 different changes to the formula. Here's what happens. You don't actually earn the whole interest rate all at once. You instead get a portion of the interest rate every time the interest is calculated. All right, so if your interest is calculated quarterly, then every 3 months you get a quarter of your amount for the year. So let's say we had an annual percentage rate of 8%, then that would mean after 3 months you would earn 2% of whatever's in the account, and then you would earn another 2% after another 3 months, okay, and then another 2% at the end of the third quarter, and your last 2% at the end of the fourth quarter. Okay. If you had a semi-annual rate, then you're only going to earn half the interest. So you would get 4% at the end of maybe June, and then 4% at the end of December. Monthly, you would only get a 12th of the interest rate. Okay, and then daily, usually in banking situations, we assume an average length a year of 365 days. So you would get a 1/365th portion of the interest rate. So in the formula, here's the change. Okay, we have A equals P times 1 plus, okay, and instead of just getting the entire interest rate R, you get R divided by N, where N is the number of times per year that the interest is compounded. So if it was, we'll go back to the 2% example here. Okay, if it was compounded quarterly, then N would be 4, and you would see a little 4 in this formula. You're getting a quarter of the interest rate. Now, the number of times that the interest is compounded will then multiply. All right, so let's say that this is, in our last example we did 3 years. Okay, so let's say it's 3 years but quarterly. Well, that would mean if we went back and did this the long way, okay, instead of doing this yearly, I would have to do this quarterly. Okay, Q's for quarters. And I would make this calculation 4 times every year for 3 years, so I would make this calculation a total of 12 times. So to account for that, in the exponent, it's not just t anymore, it's n times t. All right, so n times per year for t years. So let me fill in the specific numbers in this example with the annual percentage rate of 8%, and we'll go with interest compounded quarterly. So in that situation, we would have the principal, and I will use the 5,000 again, okay, times 1 plus the rate of 8%, but we're only getting a quarter of that each time it's compounded. And then the exponent would be n, which is 4, times the number of years, 3. Okay, so 4 times 3, that's the 12 times that interest is compounded during that time. Alright, so that's how compound interest works, and we will look at some examples and practice using this formula. Alright, so here it is. A equals P times the quantity 1 plus R over N to the NT. Alright, so a lot of these letters stand for the same things, A, R, and T. N is the new one. It's the number of times per year the interest is compounded. Right. So if it were monthly, N would be 12. If it were daily, N would be 365. If it is semi-annually, N is 2, and so forth. Alright, so that's the compound interest formula, and in the next video we'll do some examples and practice using this.